Hello everyone, my name is Mehdi Kordnavarsi. This is the second movie about the software architecture and design, chapter 3. In this part, we are going to talk about the component-based architectural style. It focuses on the decomposition of the design into individual functional or logical components that expose well-defined communication interfaces containing methods, events, and properties. This provides a higher level of abstraction than object-oriented design principles and does not focus on issues such as communication protocols and shared state. The key principle of the component-based style is the use of components that are, first, reusable. Components are usually designed to be reused in different scenarios and in different applications. However, some components may be designed for a specific task. The second key principle is replaceable. Components may be readily substituted with other similar components. And the next one is not context specific. Components are designed to operate in different environments and contexts. Specific information such as a state data should be passed to the component instead of being included in or accessed by the component. The next concern is extensible. A component can be extended from existing components to provide new behavior. The next is encapsulated. Components expose interfaces that allow the scholar to use it functionally and do not reveal details of internal process or any internal variable or state. The next one is independent. Components are designed to have minimal dependency on other components. Therefore, components can be deployed in any appropriate environment without affecting to other components or systems. Common types of components used in applications include user interface components such as grids, buttons, or often referred to as controls, and helper and utility components that expose a specific subset of functions used in other components. And other common types of components are those that are resource intensive, not frequently accessed, and must be activated using the just-in-time or JIT approach, common in remoting or distributed component scenarios. And queued components whose method call may be executed asynchronously using message queuing and store and forward. Components depend upon a mechanism within the platform that provide an environment in which they can execute, often referred to as a component architecture. Examples are the Component Object Model, or COM, and Distributed Component Object Model, or DCOM, in the Windows operating system. However, the term component is often used in the more basic sense of a constituent part, element, or ingredient. The Microsoft .NET Framework provides support for building applications using such a component-based approach. Here are two examples of the Windows platform. For example, DCOM configuration. Look at the media player or logical disk manager, and other components are gathered together to build an application. You can use easily these components to make an application. The following are the main benefits of the component-based architecture. The first, ease of deployment. As the new compatible version become available, you can replace existing version with no impact on the other components or the system as a whole. The next is reduce cost. The use of third-party components allows you to spread the costs of development and maintenance. The next one is ease of development. Components implement well-known interfaces to provide defined functionality, allowing development without impacting other parts of the system. The next one is reusable. The use of the reusable components means that they can be used to spread the development and maintenance costs across several applications or systems. The next one is mitigation of technical complexity. Components mitigate complexity through the use of a component container and its services. The next one, build composite applications that combine the and reuse components across multiple applications. Consider the component-based architectural style if you already have suitable components or can obtain suitable components from third-party supplier. Able to combine components written in different code languages. Create a pluggable or composite architecture that allows you to easily replace and update individual components. As you see in this picture, three different applications share the using of some components in the system in three levels of the components: application specific component, business components, frameworks, and system utility components frameworks. For example, here the component A is shared between application 1 and application 2. And also component 2 and 3 is shared in both application 1 and application 2. The next technique is domain-driven design architectural style. Domain-driven design, or DDD, is an object-oriented approach to designing software based on the business's domain, its elements and behaviors, and relationships between them. It aims to enable software systems that are realization of the underlying business domain. By defining a domain model expressed in the language of business domain experts. Business domain experts are the executive persons in your client. For example, the CEO or CFO or product manager, they know what exactly going on their business. We say them as a business domain experts. The domain model can be viewed as a framework from which solution can then be rationalized. To apply domain-driven design, you must have a good understanding of the business domain you want to model, or be skilled in acquiring such business knowledge. Architects, developers, and subject matter experts have diverse background, and in many environments will use different languages to describe their goals, design, and requirements. However, within domain-driven design, the whole team agrees to only use a single language that is focused on the business domain and which excludes any technical jargon. Let's see a short movie about 2 minutes about a book to discuss this technique, domain-driven design.
Through the domain-driven design approach, you and your project team will better understand the domain that you aim to serve and communicate in a common language that can ensure harmony and teamwork with your group. You will be able to finish the whole design and development process focused on what is truly essential. Thanks again for downloading this book. I hope you enjoy it. What is domain-driven design? Computer software is normally developed in order to automate the different processes we go through every day, including those improvements that advance business processes. Those business processes, or the real-life problems, are the domain of the computer software that aims to automate or solve them. If you want to study domain-driven design, your understanding should be founded on that concept that computer software is derived from and is totally connected to its domain. A lot of software programmers fail in their endeavors because they focus too much on the codes that make up the software, without focusing enough on its domain. To better creation of a car as a metaphor. A lot of workers are involved in the creation of the car, and many of them specialize in creating specific parts of the car. But because those workers only focus on specific parts, they frequently have an incomplete view of the whole creation process. Most often, they view the car as merely a collection of various parts that they need to interconnect. What those workers do not understand is that the car is much greater than its individual parts. A car that will be well accepted by the consumers actually begins from the designer's vision. The designer will have to meticulously write the car specifications that will match his vision. From that vision and specification, The designer continues to improve the design by changing and polishing the specifications until they reach perfection and become the true reflection of what the designer has originally envisioned.
As the core of the software is the domain model, which is a direct projection of his shared language. It allows the team to quickly find gaps in the software by analyzing the language around it. The creation of a common language is not merely an exercise in accepting information from the domain experts and applying it. Quite often, communication problems within development teams are due not only to misunderstanding the language of the domain, but also due to the fact that the domain's language is itself ambiguous. The following are the main benefits of the domain-driven design style. The first is the communication. All parties within a development team can use the domain model and the entities it defines to communicate between the business knowledge and requirements using a common business domain language without requiring technical jargon. The next one is extensible. The domain model is often modular and flexible, making it easy to update and extend as conditions and requirement changes. The next one is testable. The domain model objects are loosely coupled and cohesive, allowing them to be more easily tested. This picture is shown the misunderstanding and the miscommunication between the developers and system analysts. And this explains how the customer explained what it needs and how the project leader understood. They misunderstood and how they analyzed, designed it. So the analyst explained their idea to the programmer and the programmer wrote it as this picture. And the expert consultant described, no, the main exceptions of the clients is like that. So how the project was documented? Nothing. And what was installed by operation? And how the customer was billed? A lot of money they paid during the time, and how the project was supported. And the final, what the customer really needed. And this picture shows the reality in the most environments and the system analysts and the application developers. Thank you for watching this movie. In the next movie, we are going to talk about the layered architectural style. Thank you.